Hi, this is my 5th devlog, and a while ago I had a problem with stairs in my game. They didn't work. The recommendations online were to replace the stair collision mesh with ramps, which works, but isn't really a universal solution. So to fix this, every frame the player raycasts down from their maximum step height, with the start point offset from the player in the direction they're moving and in the direction they're trying to move. If either raycast hits something, the player is moved up to match the elevation of the step, so they can then move horizontally onto the stair without amassing any vertical momentum, which can cause problems. Mostly the problem of players ramping off stairs like they're on a skateboard. This also works in reverse when walking downstairs, warping the player a short distance to the floor when they walk off a stair instead of letting them fall down the stairs, which would look awful, and might switch the player to falling movement controls rather than the grounded ones, making the game more difficult to play. The only problem with all this is slopes. A sphere cast is used for the down warp to find the closest point on the ground to the player. This works on flat ground, but on a slope it leaves the player clipping into the ground, because Unity has a sphere cast, not a cylinder cast, so it returns the point closest to the player's axis instead of the closest point to the bottom of the cylinder. To fix this, I need to either use a bunch of expensive raycasts to find the closest point, or use the point the sphere casts find along with a bunch of geometry to figure out what height the player should be at. Drawing all this out in a side view leaves us with a problem you may remember from geometry class, and to ease that overwhelming sense of dread, here's a bug I never quite figured out, where dashing sent the player flying into the stratosphere. After failing to fix this for too long, I just pulled an old copy of the script, then modified it to be the same as the broken version, but now it works. For some reason. Anyway, I don't remember much of 8th grade either, so I drew out the geometry problem in Blender, then remembered the internet exists, then realized I had no good way of finding the problem I was looking for, and went back to Blender. The player's cylinder has a radius of 0.25, and so does the sphere cast. Not really, I don't want the cast hitting walls, so it's actually slightly smaller than the collider, but close enough. The sphere cast comes out of the feet of the player and hits a slope. I now need to find how far to move the player up from where the sphere cast hits so that they're touching but not inside the ground. To do this, we have the contact point, the normal vector off the slope, and the up vector of the player. I can run these last two through vector3.angle to get this angle. We now have this radius, which is also this radius, and this angle, which is also this angle. And that's it, that's all we need. And now it's just a geometry problem. Quick break, here's a mech that doesn't like putting its front left foot down. I didn't finish this system yet, but I thought it looked funny. Back to pain. These are right angles, a triangle adds up to 180 degrees, so now I have all the angles. Yay. These two triangles are similar since they have the same angles, but are they congruent? Intuitively they should be, but let's just duplicate one and move it over. So yes, they're the same size. I could also notice that these two lines are both equal to the circle radius, meaning the shape is symmetrical and the triangles are the same. This line is the radius of the cylinder, meaning these two triangle legs add up to 0.25. Let's label the hypotenuse of both triangles h, since we don't know what it is, but we do know that this leg is h times the sine of this angle. That's just a rule of triangles, you just have to know that. Now we have this equation, solve for h, and we have this. I'm using the angle of 30 degrees, so h in this case is 0.16 repeating. Checking in Blender, this answer is correct. The distance we're looking for is the total height of the triangle minus this section of the triangle. We just found h, so this segment is h cosine theta. The total height is just radius times cosine theta. This then simplifies to this, and we've cleared 8th grade. Filling in the values of theta and h from earlier, this distance should be 0.72, which Blender shows is correct. To solve our initial problem, we move the bottom of the player to the height of the hit point like the code currently does, causing this clipping problem. Then we offset by the distance we just found. Quick sanity check, running through these equations again with an angle of 0 results in 0 offset added to account for the non-existent angle of the ground, which is correct. And now, one fringe mechanic of half a system I built to make stairs work correctly is slightly less buggy. I have a newfound appreciation for things I should have learned in geometry class. And here's the circuit UI spawning at an angle after I overhauled the logic system. Yeah, the bugs in this game aren't all that funny, mostly just disappointing. This last month was me getting 3 different systems, each about 80% of the way done, which is why this video didn't go over any of them. At one point, I found myself optimizing my circuit simulation by finding and removing unused current and voltage indexes, so console logs in another part of my code wouldn't be printing those unused indexes. To make it easier to see what was going wrong with the current calculation system, which wasn't actually causing any problems for the thing I was working on, it's just its effects were indistinguishable from those caused by the thing I was actually working on, which I couldn't fix because I couldn't tell what was happening. I know I'm a bit stuck in the weeds, but at this point I feel like Dracula's gardener. It's a mess, but that's why I'm here, and going somewhere else probably won't help things. So when people ask me how the game is going, I opt for it's going slowly, rather than giving them a migraine trying to understand the mess I just said. Anyway, I hope this was interesting, or at least now you know what your geometry class was good for. Thanks for watching. Bye.